Komali Mam. In this video, I am going to teach you exemplar questions from coordination compounds chapter. And if you are you are worrying about the chemistry of your NEET and JEE preparation, and you want to excel in chemistry and you want to get a highest mark in a chemistry, but you are missing somewhere, you're not able to get it, and you want to learn in an easiest way in a short duration, and you don't want to spend max of your time for a chemistry preparation, then you can join into my online classes. I'm going to give the number in a description. Just send your 10 mark sheet and photocopy, and later on you can join into the, I will give you further details, and you can join into the course. You can excel in a chemistry, that is my promise. And let's start today's session. And in this session, what I'm going to teach you, I'm going to teach you exemplar questions from coordination compounds chapter. In an easiest way, I'm going to teach you. Let's begin the session. Let's see the first question from the coordination compounds chapter. Which of the following complex is formed by Cu plus 2 ions is more stable? They have given us 4 complexes. You need to see log K is equal to 11.6, log K is equal to 27.3, and log K is equal to 15.4, and log K is equal to 8.9. See students, they have given 4 log K values. Which log K value is more? That complex is more stable. Which log K value is more? That complex is more stable. So correct answer is option B. And let's see the second question. They are giving us that 3 complexes, and they're asking us what is the correct order of wavelength lambda. The color of the coordination compounds depends upon the crystal field splitting. Then what will be the correct order of adsorption of wavelength of light in the visible region for the complexes they are asking? As per the spectrochemical series, the correct order is, ammonia is a strong ligand. This is H2O. Ammonia is a strong, CN is a strong ligand than ammonia than the water. Okay, now this is an energy order. So we all know that E is equal to Hc by lambda. More is the energy, less will be the wavelength. Then this order becomes a reverse. We will be having H2O complex is more wavelength than ammonia than the Cn minus. So in all these 4 options, H2O is more than ammonia than a Cn. Option 3 is your correct answer. Now let's see the next question. When 0.1 mole COCl3 NH35 is treated with excess of AgNO3, 0.2 mole of AgCl are obtained, the conductivity of the solution corresponds to. See here the question, they have given the hint that 0.2 mole of AgCl is formed. So 0.2 mole AgCl is formed, which means that outside of the complex, 2 chlorines are present. See how I'm going to write CO NH35 Cl. We need to maintain 6 is the coordination number over here. Outside I'm writing 2 Cl2s. Ma'am, why ma'am you're writing outside 2 chlorines? You can bring 1 ammonia, right? Outside there is a possibility, right? But no, because I am getting here 0.2 mole. 1 mole producing 2 chlorine, then 0.2 moles produces 0.1 mole produces 0.2 mole chlorine. So if I treat this with AgNO3, then I'll be getting 2 moles of AgCl. If 1 mole is producing 2 moles, then if it is a 0.1, it produces 0.2 of AgCl. This is what type of solution it is. It is 1 ion which is what is present inside the coordination sphere. It won't break, so it is 1, and it is producing 2 chlorine ions, so it is 1:2 type of an electrolyte. Let's see the question number 4. When 1 mole CrCl3 6H2O is treated with excess of AgNO3, 3 mole AgCl are obtained. The formula of the complex is, here based on a previous question, you can solve this question very easily. They're asking us 3 mole of AgCl is obtained, which means that 3 Cls are outside of the coordination sphere. Here 3 chlorine are outside of the coordination sphere. That's why whenever we treat with AgNO3, we are getting 3 mole of AgCl are obtained. So the correct formula of the complex is CrH2O6Cl3. Option 4 is our correct answer. The correct IUPAC name of this complex, 2 ammonias are there, so diamine, and 2 chlorine are there, dichlorido. And platinum, what is oxidation state of a platinum? Ammonia is a neutral ligand, chlorine is an negatively charged monodentate ligand. There is no charge on the complex, so total you make it sum equal to 0. Then oxidation state of a platinum is 2. Then in all these 4 options, first option is having 2. Diamine, correct, because as per alphabetical order, A comes first than the C. Diamine, dichlorido, platinum 2 is the correct answer. Now let's see the next question. The stabilization of coordination complexes is due to chelation, that is called as chelate effect. Which of the following is the more stable complex? Do you understand the meaning of a chelate? Chelate means that which is forming a ring. CO is a monodentate ligand, Cn minus also monodentate ligand, but oxalate ion, which is a bidentate ligand, and it forms a ring kind of structure to the central atom. That's why it is called as a chelate complex, and it is the more stable complex. Whereas H2O is also a monodentate ligand. Option C is our correct answer. Let's see the next question. Indicate the complex ion which shows the geometrical isomerism. Yes, now in this 4, which is showing a geometrical isomerism, this is a central atom M, and here H2O is a 4 different ligands, and B2, Ma4B2, Ma4B2 complex it is. Next one is Ma3B complex, next one is Ma6 complex, and then next one is M 5 CNs is there, so A5, and NC means B type of complex. In all these complexes only it shows a geometrical isomerism. Students, I uploaded 2 videos based on geometrical isomerism. Those 2 are the best videos. Please, if you are not at watched, you go through those 2 videos and make a notes of that. You feel awesome about that concept. You solve any kind of questions easily regarding that particular tough topic, geometrical isomerism. 2 tricks I uploaded, and in this case you can observe Ma4B2 shows an isomerism. I will ask you a question. Can you tell me, if 2 B's are opposite, then what kind of isomerism it shows? Cis or trans? Cis or trans? It shows which isomerism? Trans isomerism. Very good, it's a trans isomer. If 2 B's are adjacent, can you tell me what kind of isomerism it shows? It shows an isomerism which is called as cis. So cis trans isomerism was exhibited by only the first complex. If you draw, then for the here all are same. No, here you can't make any cis or trans, because all are 5, almost 5 are same. Any 2 ligands should be different, then only they can show the cis trans isomerism. See the next question. The CFSC for octahedral complex is given, and they're asking for tetrahedral complex. Whenever we see this question, we feel that how to solve this kind of question, but I'm going to tell you, see, this is the easiest problem. Delta T is equal to 4 by 9 delta naught is the formula to find it out. Then 4 by 9 delta naught is already given in question, that is 18,000 centimeter inverse. 9 ones are 92000. Then 8,000 centimeter inverse is our right answer. Option C is the correct answer. Now see the next question. They have given us 2 complexes, and they're asking us what type of isomerism. If you observe here, in this case sulfur is a donor, and in this case nitrogen is a donor. When if you see thiosulfate ion, sulfur can donate, NCS, nitrogen can donate. In the same ligand, if two donors are present, we call those ligands as ambidentate ligands. What we say, students, we call it as ambidentate ligands. So ambidentate ligands, their linkage is different here. Atom which is donating is different. So we call it as a linkage isomerism. Through which atom it is linked to the central atom, it is different. That's why it is an example for linkage isomerism. And now see the next question, what type of isomerism it is. If you dissolve this particular complex in a water, it produces Br minus and it produces Cl minus. So it is producing two different ions. That's why it is an example for ionization isomerism. What type of isomerism? Ionization isomerism, because the number of ions producing is different. That's why it is an example for ionization isomerism. See the next question. A chelating agent has two or more than two donor atoms bonded to a single metal ion, and which of the following is not a chelating agent? Chelating agent means the one which is not forming a ring. We call it as a chelating agent. SCN, if you see, it can donate either through sulfur or either through nitrogen, but in both the cases it cannot donate at a time, either sulfur or a nitrogen, so it cannot form a chelate. But if you see oxalate, both oxygens can act as a donor and it can form a chelate. Glycinate ion, you can see here NH2 CH2 CO minus. So here oxygen can donate, and in a NH2 nitrogen can donate and it can form a chelate. And ethane diamine, if you see in a different ways, you can draw the structure. No need to worry for ma'am, why are you drawing like this? I am drawing in a, no problem. Just you need to show, like, see how a chelate, lone pair on this nitrogen can donate, lone pair on this nitrogen can donate. So ethane 1,2 diamine is also a chelating agent. First option, thiosulfate ion, only not a chelating agent. It is an ambidentate ligand which is having more than one donor atom. Now, which of the following species is not expected to be a ligand? In these four options, which is not a ligand? NO is a ligand, nitrosyl ion. Ethane diamine is a ligand because two donors are present. CO can donate. All these are the ligands. But ammonium ion, ammonia, which is already donated H plus ions, it's a lone pair to the H plus ion. So it is forming ammonium ion. So it is not having any lone pair to donate. That's why it is not an ligand, which is already formed four bonds. It cannot form. That's why it is the correct answer. Ammonium ion is the correct answer. See the next question. What kind of isomerism it exhibits between these two complexes? The first complex is CrH2O6Cl3, and the next complex is CrH2O5Cl, and here I'm seeing this complex, I'm showing this complex Cl2H2O. This is the complex. The difference between both the complexes is a water molecule. Here outside there is no water molecule, and here one water molecule is present. So this comes under a kind of ionization, I mean hydrate isomerism, because water molecules are different. Even chlorine also different here and here, but when both are there, you need to give priority for the hydrate isomerism, which is also known as solvate isomerism. Solvate isomerism, hydrate isomerism, which is also known as solvate isomerism. Now see the next question. The correct IUPAC name of a complex. See, two ammonias are there, diamine, and one chlorine is there, chlorido. Diamine, chlorido, both are correct. Nitrito N, both are correct. Why it is a nitrito N? Because nitrogen can donate, or oxygen also can donate. It is an ambidentate ligand. Two donors are present. If they have given nitrito O, means oxygen is a donor. Here nitrito N, because nitrogen is a donor. And then platinum 2 is a correct answer, because here this is Cl, PT, ammonia is a neutral ligand, and then chlorine oxidation state is -1 and NO2 is -1. There is no charge on a total complex, so it is 0. Then platinum, we get a +2 oxidation state. Platinum 2 is correct answer. Platinate is not correct because there is no charge on a complex. Positive charge is not there. So, negative charge is not there. No charge. So you should not say 8 and all. And coming to this, I want to tell you one more point here. NO2 is present. So NO2, it acts as a positive ligand as well as a negative ligand. Ma'am, when I should consider it as a positive, when I should consider it as a negative. For example, if you consider here, if you take as a positive ligand here, then platinum charge becomes 0. No. Central, if you consider here a +1 as an NO2, then platinum gets a positive 0 charge, whereas no, platinum exists in +2 as well as a +4. These are the more stable states. That's why, NO2, we need to consider it as a negatively charged ligand. Diamine chlorido nitrito N platinum 2 is the correct name of the complex. These are the questions from coordination compounds, exemplar questions from the coordination compounds chapter. And take your exemplar textbook and solve these questions. In a next session, I will select a few more important concepts where students need it. My name is Komali. I'm your chemistry mentor. Thank you so much for watching this video. In a channel, many tricks are there. Go through those tricks and get a benefit of the channel. Thank you so much.